Good evening, my dear 10th standard students. In this video, we are going to study about the topic electrical energy. In the previous lectures, we have studied that the free electrons are responsible for the current flow through a conducting wire. Can these electrons flow inside the conductor and produce a current in the absence of a battery? No, it cannot. Why? Then what is the role of the battery here? You are absolutely right. The battery establishes a potential difference. Only when there is a potential difference across the two ends of the conductor, then can be a flow of current through it. So, here, who is responsible for the potential difference across the conductor is the battery. You can see the battery is connected across the conductor. The battery converts what? Chemical energy into electrical energy. And this electrical energy only is responsible for pushing a q coulomb of charges from one end of the conductor to the other end of the conductor. Okay, now you see that the free electrons are moving from the end y towards the end x, because x is at the positive potential. So, who is doing the work in pushing the charges is the battery. Already we have defined the potential difference V is equal to the work done divided by the charge Q. So potential difference itself is defined as what? The work done per unit charge. So from this equation, the work done also can be written as what? V into Q. So work done is equal to the product of the potential difference and the quantity of charges flowing through the conductor. And this work done only is called the electrical energy, and since it is energy, the unit is joule. Now, from the definition of electric current, what is electric current? I is equal to what? Q divided by T, and therefore what is Q is equal to I into T. I am going to substitute for Q equal to I into T. Therefore, substituting Q is equal to I into T, W is equal to V into I into T. So, this is another expression for the electrical energy, VIT joule. So, V is in volt, and I is in ampere, and T is in second. And this unit is what? A volt, and this unit is what? A coulomb. So, this is also a volt into coulomb. And from this volt into ampere into second, or the general unit is what? A joule. So, electrical energy is given by the two expressions. The first expression is electrical energy, W is equal to the product of potential difference and the quantity of charge flowing through the conductor. And from this expression, the electrical energy W is also equal to the product of the potential difference and the current into time taken, VIT joule. Okay. Now, the next topic is electric power. We have studied in the 9th standard one chapter, work, energy and power. How will you define power first of all in general? Yes, yourself. Power is defined as the rate of doing work. You are right. So like that, now electric power we are going to define. So electric power also is denoted by the same symbol P only. So this must be equal to what? Work done divided by time. This work done in driving the free electrons, charges through the conductor only is called as electrical energy. So this is equal to electrical energy. So this is electrical energy consumed divided by the time taken. This is time taken. So this is called as what? Rate of consumption of electrical energy. So rate of consumption of electrical energy. So this is electrical energy, or the rate at which energy is dissipated. So this is equal to W by T. W is V into I into T, and this is once again divided by time T. So this T and T get cancelled. This implies power P is equal to V into I. You see that this is the very important expression. We find that electric power, therefore electric power is equal to the product. Electric power is equal to the product of potential difference and the current. This is one of the expressions for electric power. We have shown that electric power is a product of the voltage and the current. But from Ohm's law, we can substitute V equal to I into R. So, V is equal to I into R. So, this implies power P is equal to IR into I. So, this is also equal to what? I square into R. This is one of the equations. So, power also can be expressed in this form. So, first equation for power is what? P equal to V into I. By substituting from Ohm's law V equal to I into R, we get another equation for power, that is equal to what? I square into R. Or in the first equation, we can also substitute from Ohm's law, I is also equal to what? V by R. So, I is equal to V divided by R. This, if you substitute, means power P is equal to V into V divided by R, and this is equal to what? V square divided by R. This is another equation. Okay, this is another equation. So, these are the three equations for the electric power and the SI unit. The unit of electric power. SI unit of power is already we have studied watt, W-A-T-T, and the symbol for watt is capital W. So, how we have expressed the definition of electric power. Electric power is defined as the rate at which electrical energy is consumed or liberated. Okay, so this is the definition for electric power. From definition of electric power, P equal to W by T, but W is also equal to VIT, that is electrical energy, divided by time. T gets cancelled and hence we get the general expression for electric power is the product of the voltage and the current. Now, what is the SI unit of electric power? Watt. Watt is the unit, but 1 watt is a very small unit. Now, in power stations and all, how much units of power is being generated means it is in megawatt. Like that, the iron box, the AC, refrigerator and all, they consume the electric power in kilowatts. So, there are some other units. So, the kilowatt is also equal to 10 to the power of 3 watt. Another unit I told you, megawatt. So, this megawatt is also equal to 10 to the power of 6 watt. 10 power 6, 1000 into 1000. Now, in olden days, another unit was used, that is called as the horsepower. Even now, if you go to the electrical shop, the power of the electric motors and all are expressed in terms of what? Horsepower only. Even now, it is in use. So, let us say that horsepower. This horsepower is HP, and 1 horsepower is also equal to 746 watt. 746 watt. So, these are all the different units of electric power, but the SI unit of electric power means we should say that it is watt. And 1 kilowatt is 1000 watt or 10 power 3 watt. 1 megawatt is what? 1 million watt, that is 10 power 6 watt. And 1 horsepower is equal to what? 746 watt. Okay, students, have you understood the two definitions and expressions we have studied today? One is what? Electrical energy. Electrical energy is defined as the work done in moving a Q coulomb of charge from one end to the other end of the conductor. And the expression for electrical energy is given by W is equal to V into Q, or W is equal to VIT joule. Similarly, electric power is defined as the rate at which electrical energy is consumed or liberated. And the three expressions for electric power, what we have studied? Yes, power P is equal to V into I, potential difference into current. Or power P is also equal to I square R. Or power P is also equal to what? V square by R. Okay, students, now another very interesting topic we are going to see. Until then, shall I erase the board? Okay, good.